just so you don't forget, on Tuesday you're going to expect your last lecture class covering chapter 14 and chapter 15. And then Thursday is when you're going to have your last lab exam. This last lecture will be very short and then you're done by 2:41. And take by 2:42 minutes. The thing about you guys, don't forget, it's not over yet. A lot of the students, you're sitting, you're very comfortable, and you get antsy. Towards the end, it's just a natural tendency to just get so excited. Just can't wait to be over. So don't just hang in there and still study, still study. So you still do well. Remember your final exam, 200 points. Lab exam, 100 points, right? So still try and be in the study mode, not in the vacation mode yet. Okay. Vacation mode after your final exam. Then you're going to enjoy your vacation. Okay. We just have a little more to cover and then you're all done. So if you're gonna sign up, by the way, for summer, do it right away, okay?
Thanks to Wendy saying that, I went home and signed up for it.
Oh, you did?
Yeah. I've been doing school ever since, straight through since last summer. Last summer was my first quarter.
Some ways you should.
It's hard because it's so short. You have to learn all this internet information with a month less time. Imagine learning all this in 2 months.
But we try and make it not as hard as that's it. Okay, so here's your eye. So we finished the function of the outermost layer, right? The cornea and then the sclera. Remember, there's the three layers of the eye: the outermost layer or the fibrous layer, tunica fibrosa, then the middle layer, tunica uvea, then the innermost layer, which is your retina or the nervous layer. If you don't remember the names of the layers, you just write outer, middle, and inner layer. And you saw this when you did the section. What happened to the eye? Never mind. Okay, so here. So now we finished this outer. Remember, it's the sclera and the cornea which makes it closed. But if you look at the middle layer, the tunica uvea, you see the choroid, the ciliary body right here, and then the iris. So it's open right there. There's the pupil. It's only the outermost layer that makes it close. And then you look at the inner layer, which is the retina. It ends right there. And this is a view of the retina. This is all just retina. Okay? Tell me if you are confused. So look at what the retina is made of. It's made up of all neurons. Okay? But look at, there's another part to the retina. So the retina is made up of mainly neurons that sit on a bed of, what is this tissue type? What do you think? Epithelium. It's epithelium, right? Don't forget your 4 basic tissue types for your final exam. Epithelium, connective, muscle, and nervous tissue. Okay? Huh? Okay, so this epithelium, so again, the retina is mainly 2 parts. The neurons sitting on a bed of epithelium. This bed is called pigment epithelium. What pigment? Yes, very good. Do you remember when you did your eye dissection, remember the second layer, the tunica uvea, it was dark. And you remember the function of melanin in your eye is to absorb stray light. So look at, if this is your eye, right? The eye, and this is the person you want to see. If there's too much light, you won't be able to see. And you remember that at the second layer, the tunica uvea, before this layer, can you picture that? This is already lots of melanin pigments absorbing stray light. And even when it enters your retina, if there's still lots of light there, you will still, that extra light will still be absorbed by your pigment epithelium. Okay? It's very important just the right amount of light will enter your retina. So that's the function of this one, number one. Number two, there's another very important function of your pigment epithelium. It stores vitamin A. Vitamin A. Vitamin A is what we need to see. Okay? Do you see this? It says the pathway of light. So I'm going to draw this person that I want to see again. And there's my eye. You see that if you notice, it doesn't make sense. Look at this one. So we see because the light waves bounces off of you, and that's what enters me. So look at the white light waves bounces off of this one, enter my eyes. And it doesn't make sense. You may question, how come the light waves, see the path of light, it will pass through these neurons, the ganglion neurons, then the bipolar neurons. And yet these two neurons do not even respond to the light. Here is where you really appreciate the word specificity, right? Neurons are very specific to the stimulus that they respond to. These are not photoreceptors. So even though the light will pass through this one and this one, they don't respond. Only photoreceptors do that. Do you understand? Everybody? One more time. The light passes, see? Passing through the first layer of neurons that it will encounter in the retina, ganglion. Will it generate action potential? No. How about this one? No. Only photoreceptors. That's what they're called. They respond to light. What you know of rods and cones? That's this one. Those are the photoreceptors. And if you look at these photoreceptors right here, this is shaped like a cone, that's why it's called cones. This is shaped like a rod, that's why it's called rods. Right here, see, there's my rods and there's my cones. And do you see these discs right here? These discs, that one is made up of vitamin A. And here is how you see. It's the vitamin A inside your photoreceptors. See? The vitamin A is in the cis form. When the light hits the vitamin A inside your photoreceptors, it changes in shape from cis to trans, and that's the one that fires or generates action potential. So the conversion of vitamin A from cis to trans, you don't need to know that, but that's the one that's key for converting the light waves to a nerve impulse. Then from photoreceptors, synapse with the bipolar, with the ganglion, go to the occipital lobe. Then you interpret that as something you see. Do you follow so far? Everybody? No? No?
Go over it again.
Again, here. What is it?
The fighter, the where they changed the state into the trans from
Okay.
there.
What?
When this is what the photoreceptors do with the vitamins.
What the photoreceptors
I don't
do
know.
with
That's
the
why
vitamins?
I don't know what I don't know. I just know that. Never mind.
The vitamin A, this is your photoreceptor. What is the photoreceptor made of? Vitamin A.
Okay.
That's it, see? And it's the vitamin A in there. So the light waves, when they hit the vitamin A, it changes the configuration. Vitamin A is a compound, right? An organic compound. You remember Krebs cycle? We studied Krebs cycle. That's you break the bonds. Same thing here. That's the same thing. What happens? You change the configuration. The changing of the configuration in your rods and the cones. That's the key for powering up an electrical impulse. So from light stimulus, it now is converted to an electrical impulse. You see, you heard of night blindness? You heard of that?
Mhm.
Right? And night blindness is because of deficiency of vitamin A. And that is because it is actually, you understand? You get that? It's actually the vitamin A here that is reacting with the light stimulus to change that light stimulus to nerve impulse. What do neurons propagate? Nerve impulse. Another term for nerve impulse is action potential. So that's what's going on. Your light waves now, you cannot process, like you process nerve impulse. That's what the brain processes. So that's what happens. The opening of the gates, etc. But here, the key is vitamin A. You got that? Okay. So again, the light passes through this. Will this fire? No. Will this fire? No. Okay. Only this one. And then after it fire, you see, look at, because it's the vitamin A here, really, that's the key for action potential. You see how very important this one is? It stores vitamin A. In fact, they say your pigment epithelium stores up to 4 months worth of vitamin A. So that even though you're lacking in vitamin, it's so important to vision. You will be blind. Now, the two photoreceptors are your rods and your cones. And they say you have about 120 million rods, 6 million cones. But the location, the reason why the most common symptom of vitamin A deficiency, they say, is night blindness. But both rods, you know that the rods is for night vision or to see in the dark. It's your rods help you see in the dark. The cones is for color vision or help you see during the day. Both of them are affected by vitamin A deficiency. But there's a difference in the way the rods and the cones are distributed in your retina. The rods are spread apart, but the cones are clumped together in a central fovea right there because they're so concentrated in one area. Even though they're both affected by vitamin A deficiency, the rods will suffer more than this one because they're so concentrated. So you will say, I can't see very well in the dark. But in fact, both of them are compromised by vitamin A deficiency. Does it make sense, everybody? Okay, now let's look at how this nerves leave the eyeball. So here is the picture again. There's the person I want to see. You follow? Then it's going to bump. So here's I'm going to just use this pic. I'm just going to use this one over here. So it's the path of light. It's going to stimulate this one first, number one, the rods and the cones, okay? And then the rods and the cones will synapse with this second group of neurons. The second group is called bipolar neurons. And I hope you remember, look at the shape, bipolar, right? So this is neuron number two. So the pathway of light is it goes to this one, number one, and then it bumps off to number two, which is the bipolar. And then next synapse with the number three, which is your ganglion neurons. So from photoreceptors, so the light go to photoreceptors. Then the photoreceptors will then convert the light stimulus to nerve impulse or action potential because of vitamin A. Then photoreceptors will synapse with my bipolar neurons, then synapse with ganglion neurons, which is the neuron number 3 here. And if you look at this one, the axons, so there's the cell bodies of my ganglion neurons. All of the axons of the ganglion neurons, look, they will all come out of one area in your eyeball. This one, called your blind spot or the optic disc. You really do not see from your blind spot because there are no photoreceptors there. This blind spot is just occupied by the axons of the ganglion neurons as they leave. And when they leave, this is what you saw when you did your eye dissection. This is the optic nerve. You understand? Everybody? Okay? So one more time, there's my pathway. The light will go to what? Photoreceptors, right? So light acted by photoreceptors, you convert the light stimulus to what? Action potential. Then photoreceptors synapse with bipolar neurons. Then bipolar synapse with ganglion. Then the axons of the ganglion finally leave to go to the occipital lobe, right? It has to go to the occipital lobe. They have to leave through the eyeball. The part of the eyeball where they leave is blind. That's your blind spot because it's absent of any photoreceptors. So now I'm going to trace the pathway of this optic nerve. This is your optic nerve. You understand, everybody? Yes? Okay. Now let's go look at this pathway of the optic nerve over here. This one, in the past tests, there was always this picture in the past lecture tests. So don't forget, in the past lecture test, I always had a picture of this refraction, remember? And always there was a picture of the nose, remember? The olfactory epithelium. Don't forget, you need to remember, where do you smell? You smell from your olfactory epithelium. And then in the past, there was also always a picture of the tongue where you're supposed to tell me the area of coverage of the 3 cranial nerves, 7, 9, and 10. Then I said, usually in my past test, there was always the refraction, this one, or this one, right? Emetropia, myopia, hyperopia, and don't forget presbyopia. And now, I'm also showing you this one. There was always this picture too. Maybe you will have the same. I don't know, okay? So, here we're going to continue the story. So, there's now the optic nerve. There's the optic nerve. And you will notice, look at, as it leaves, the optic nerve separates into 2 fibers. The lateral fibers from the lateral side of your eyeball, and the medial fibers from the medial side of your eyeball. See? You notice that the lateral fibers of this eyeball will stay on the same hemisphere, but the medial fibers will cross over to the opposite hemisphere. Okay? So you need to know proper terms. In the past, students were asked to point an arrow, where just like you were asked to point arrows in your test, right? It will be the same here. So this one is the optic nerve right here. This is your optic nerve, right? There's arrows, see? Optic nerves. And then when it crosses over, it's properly labeled for you. This part where they X, the crossover, that's called the optic chiasm. Then after the optic chiasm, this is now called optic tracts. You see it's labeled. You see the arrows? And the optic tracts will end in the thalamus. Remember, your thalamus is the relay station. So from the thalamus, it will radiate to your occipital lobe. So this is called optic radiations. So remember to properly identify those different structures. So beginning with the optic nerve. Then, usually students will be asked, okay, predict what will happen if there is a transverse cut like this. What do you think will happen? You will be blind. That's not a complete answer. You'll be blind completely from your left eye, right? I cut everything, so I really cannot see from the left eye. Okay? What about, because sometimes it can be just maybe the cut is right there, the medial. So you're going to say, I won't be able to see from the medial side or nasal and temporal, from the temporal or medial side of my eyeball. Be very specific for that part of the test. Huh?
What cut would be for that part?
Look at, there's a cut on the green.
Yeah.
So if that's the only one that was severed, I won't be able to see from the medial side of my left eyeball, right? Okay. How about, what if the cut was this way?
You would be complete.
Not
You'd be
really
able to see
completely.
laterally.
I won't be able to see from the nasal side of both eyes. I just cut this way. See, the lateral is still going. You see the lateral fiber still going. Don't forget that it's only the medial fibers that cross over. When will you be completely blind? If your cut is that way. If the cut that way, completely blind from both eyes. Okay?
So if we cut on one side, another one side blind or something.
Just
That's
remember,
different.
if you remember that the medial will cross over, I'm sure you won't have any problem. Wherever I do a cut, you won't have a. How about this one? If this was cut, here, that's cut right there. What will be your problem?
The left side has problems, right?
The right side from the temporal, you can see, yes, and the left side from the nasal, right? Right?
So
You just trace the fibers. Maybe you want to use different colors to remind you. Just remember that the medial side will cross over.
so if we cut right side, we have problem on left side.
It depends.
Huh?
It depends.
Oh.
Again, you see this one? I cut this.
Uh-huh.
So look at, you trace the black. I won't be able to see the lateral side of my right eye. I trace the green. I won't be able to see the nasal side of my left eye. Look at, just trace. Okay? I'm sure you won't have a hard time. Just remember, the medial crosses over, optic chiasm, the lateral stays. How about if you have a stroke here on your occipital lobe? You can't interpret, right? You can't interpret what you see. So you can't really assess if the patient sees something or not. That's called neural blindness, cerebral blindness. Okay? So
Do they know they're seeing something?
it depends if it's just one lobe. If it's just one lobe. They just can't say what it is that they see because this is the one that's supposed to interpret. So hopefully if this comes out, you won't make a mistake. Be very specific. If you just wrote blind, I'll mark you wrong. Because they're blind, right? I just want to know that you know where. Okay? The right side, the lateral. Just trace. Don't forget. You don't be surprised if I marked you wrong. I want you to be specific. Okay? So, do you have any questions on the eye? Now we're going to look at the ear. This is the last. This is your last topic for Bio 241. There's your ear, and here it is. And the ear is the one for hearing and for balance, equilibrium, movement. This is the one that helps us know whether we're going up, down, or you're lying down, you're shaking, or nodding yes. This is the one. So there are three parts to the ear. In the past, also, there was a picture of the ear in the past. Maybe you will again. And the students were asked to identify which one is the external ear, which one is the middle ear, and which one is the inner ear. So there's three parts. The external ear is this one from your auricle all the way to the tympanic membrane. That's your external ear. The middle ear is from the tympanic membrane to these two windows here, the oval window and the round window. That's your middle ear. See? Middle ear. And then from here on is your inner ear. So first, let's look at the external ear. Is there a function to the parts that you see from the external? What's the function? It's true, yeah. It funnels the sound waves, right? That's why if you see a person with those pointy ears or cupped like that, be careful what you say. They can hear better. So, but that's when, like the dogs, right? If they hear something, their ears just go up like that. It just
Alert.
funnels all the sound waves that way. Okay, and I know you know that we all have earwax. What's the proper term for earwax? Earwax. So we have earwax there from your cerumen. That's right, from your ceruminous glands, and that's very important, right? They have acidic pH. You know, there's always bacteria here. So to prevent bacterial infection, that earwax is proof that your glands are working. Okay, so let's look at how let's look at this middle ear. Next to middle ear, please write it is air filled. Your middle ear is air filled. The inner ear is fluid filled. Before I forget, okay? So this middle ear is made up of the three smallest bones in the body, the malleus, the incus, and the stapes. The auditory ossicles. You familiar with miso soup? Okay, good. So the tympanic membrane, you see this one, the tympanic membrane, it joins the malleus. The malleus joins the incus, incus to stapes, and stapes sits on that oval window, miso. Okay? They are freely movable joints. So this is how we hear. Before we figure out how we hear, let's look at this inner ear. Okay? So you okay here so far? By the way, there's this tube over here called the eustachian tube or the auditory tube. This one connects to your throat to equalize the pressure there. So I'm sure you know that sometimes when you fly, right, you have to open your mouth to equalize the pressure. And that's really what happens. You'll see, okay? So now I want to look at this inner ear. The inner ear has three parts. You see this one? There's three parts to the inner ear. This one. Study this for your lab exam, okay? There's three parts to the inner ear. This big one, the round like a snail, this is your cochlea. Then the bulge right there in the center over here, this is the vestibule. And this one, like circles, that's called semicircular canals. So cochlea, vestibule, then the semicircular canals. It's not a complete circle, I think. That's why it's called semicircular canals. Okay? So I want to look at the inner ear. This is how the inner ear looks like. It's actually filled with fluid. That's why you say fluid filled. So there it is, this part right here. So they just magnified that here. There's my cochlea, there's my vestibule, and there's my semicircular canals. And you see the blue one inside, that's fluid. Okay? So the inner ear, all of the inner ear is filled with fluid. So here's another picture right here. Okay? And the best way to study the physiology of hearing is to uncoil this part. The cochlea is the part of the inner ear that helps us hear. This vestibule is just the one that's responsible for static and dynamic echoing. Your position, you're going up or down, you're moving forward. This is the one. This semicircular canals is your movement, detects any kind of movement. Okay, so let's look at this cochlea first, which is the one responsible for hearing. All of these sensations, by the way, go to cranial nerve number 8, your vestibulocochlear nerve. Okay, so I am going to uncoil the cochlea. It's easier to study hearing that way. Okay, so let's uncoil it like this. Okay, so look, just like what do you call, like a glass of water, and you put a straw in the center. So just imagine, like, so there's a glass of water and you put a straw in the center. Okay, and this is filled with water. That's the same thing. There's your straw, there's your water, it's surrounded by water. Can you picture in your head? So this is your inner ear. You see it's filled with fluid. And you see that here there's two windows, the oval window and the round window. Okay? The window is covered by a thin membrane. You notice that the stapes sits on the oval window. Remember, miso. Stapes sitting on the oval window. Miso soup, okay? I hope that will help you remember. Because there's two windows here. This is called oval window, and this is called round window. So here in the cochlea, this central part is what we call the organ of Corti. The organ of Corti. That's like your straw in the center. That is my organ of Corti. In the organ of Corti is where you will find your hair cells, which are the nerve endings of cranial nerve number 8. Do you follow? So, one more time, this is my cochlea. I uncoiled, okay? And the cochlea is filled with fluid, and right in the center is what we call the organ of Corti. It's a nervous structure, the composition of which is hair cells. The hair cells are covered on top by a membrane. There's a membrane. You call that membrane tectorial membrane. Tectorial membrane. And so, do you understand so far? Okay, look at that. There's fluid all around. So, do you know of a waterbed? When you lay down on the waterbed, okay. So look at the sound waves. I'm going to go to the next slide over here. Look at what happens. Oh, this one. Where's that? Oh, I can use this one. I'll use this slide over here. Look what happens. the sound waves, right, will bang like the gong. You know that the sound waves, have you ever been to the disco and you see the speaker really popping? And that's really what's going on. And it's true that sometimes the sound can break a window, won't it? In the movies. But it can happen. The sound waves will be collected and it will bang on this tympanic membrane. And the tympanic membrane is what? Is joined to the meso, malleus, and they are really freely movable joints. So eventually the staves will step on the oval window. And what's here? Fluid, water bed. See? So what will happen? The water will cause a wave, and so it's going to brush on this tectorial membrane, which will brush the hair cells. Mechanoreceptors generate action potential. Go to cranial nerve number 8. Go to temporal lobe. You hear. You understand? Very easy, isn't it? One more time. What is it that's collected? Sound waves. Bang on your tympanic membrane, which then will transfer that vibration or pressure to my meso. Malleus incus stapes, right? Stapes will finally transfer that pressure onto my oval window. So the oval window will cause the water bed to move, wave current, which then will cause the tectorial membrane to brush against my organ of Corti, the hair cells. So when the hair cells get their mechanoreceptors, those hair cells generate action potential. Go to cranial nerve number 8, temporal lobe, you hear. You understand? Very easy, isn't it? So that's why you see the waves go all the way, all the way, all the way. When it goes to the round window, the round window pops out, then it becomes calm all over again until there's a new round of sound waves. There's something I want you to know about this. Do you understand this slide, everybody? What do you think? It's easy, right? Just think water bed, water all around. Think hair cells, and think sound waves. That's all. The sound waves will cause a current of the water. And then the current will brush against that membrane, which is so close to the hair cells. So the hair cells will just move like that. You generate action potential. Okay? Did you notice these hair cells? They are nerve endings. Okay? They can be prone to damage. And it's very easy to damage that one. Actually, yes, Chanel.
So can you explain what happens when you get swimmer's ear?
Oh, that's your middle ear. The swimmer's ear, when you have, the swimmer's ear is an otitis media, right here, right? In general, it happens here from moistness because there's always bacteria here. So when you, after swimming, especially the kids, they don't really wipe their ears very well, maybe. And the nice moistness there is a very nice recipe for bacterial overgrowth. So they're going to have infection in this area, coupled with poor oral hygiene. So there's a connection right there. So and kids sometimes, you say toothbrush, they toothbrush 1 second, they're done. There's still lots of germs in there. Coupled with the moistness here, that's ideal recipe for bacteria, and they just creep up here, and so it affects their hair. It's itchy. There's something that comes out. Of course, it's treatable, right?
Yeah.
But just I always use my. Oh, I'm on record, but I always use the example the old people. I always tell my daughter, you want to be like, you want to be like your grandma, losing the teeth, that will happen to you. You have to tell them brush the teeth because the germs are when they sleep. right? Germs are there. Okay? Yes.
May I share a story with you?
Huh?
I had a colleague, when her daughter was 5 years old, she had hard hearing. When mom talked to her, she said, "What?" Uh-huh. And then mom took her to hospital after a while and found her earphones. So that took 5 days to remove it.
Oh my goodness.
She's the earwax. So the doctor had
Earwax,
to
yeah.
put some a little liquid, then
Yeah,
remove that little by little. Took
yeah.
5 days.
They can plug up. Okay. One thing you need to know. Didn't you remember? This is going to come out in your test. Well, no. In the past, it came out. Remember that these three bones freely movable. And you saw, I told you right here in the middle, in the inner ear, I told you the waves. You know, if the current is too strong, don't you think so? It can damage those precious nerves. Does it make sense?
Yeah.
Okay? So there are two very important muscles here that came out in the test before. This tensor tympani muscle and the stapedius muscle right here. This tensor tympani muscle, these are the two smallest muscles in the body. Very fragile, very easy to damage. Look at what the tensor tympani does. Tensor tympani. It tenses the tympanic membrane. Then the stapedius muscle does the same thing. In other words, these two muscles, the result of the contraction of these two muscles is that the normal sounds that we hear is actually a muffled version of the actual sound waves. Because if without this, you can easily damage your hair cells. Does it make sense? And this can be damaged like with a loud blast. Sometimes that gets damaged, and then you damage the cranial nerve number 8. You can't hear anymore,
And that's
right?
when their ears bleed.
There what? Yes, sometimes, yes. Or you know how, especially with the kids now, they have the earphones. You walk by, you can hear them. The sound is so loud. Can you imagine what they're doing to these very precious, very fine, fragile muscles? This can get injured. And so what happens? Do you agree? I will tell you that when this gets injured, I hope you agree, that means your hearing is better.
Huh?
Yeah.
Yeah,
That's not muffled.
because
Most
it's
certainly.
no longer muffled. Do you agree? It's just supposed to muffle. So when you cut this, all of a sudden you hear better. And so all of a sudden the kids will say, wow, I hear better. No, that's a sign that your hearing is going down. It's damaged. There's nothing anymore. So which means it's just going to freely bang all the way to the to the cranial nerve number 8. So that's why even when you're cutting the grass, you're supposed to wear those, what do you call it? Mufflers? Whatever you call it, right? We want to protect our ears. We want to protect the cranial nerve number 8. Okay? Even with a simple aspirin, those pain medications, which sometimes we get a headache, we take that. We have stomach, take that. Dysmenorrhea, take that all the time. It is ototoxic.
Is
Okay.
it possible when if we expose into a very loud area, we can keep our mouth open? That's good for year. Is that true? My friend, I had a friend. He majored in physics. He told me if you heard something very loudly, in order to protect your ear, we have to keep
Open
our
your-
yeah.
Oh, the reason you open your mouth is because you want to let the pressure. So that's a good idea.
Huh?
That's a good idea. See, look at
Once it starts when you yawn and your ears pop.
yeah.
Mm.
See, look. That's a very good idea. See, you're going to, because every time you bang, the waves, it equalizes back here in the round window. And if you always keep your mouth open, so at least it's very quick to relieve the pressure. But just don't be around loud noises. Try to control the sound. Yes.
When you say that it makes the noise louder because it can't muffle it, is that like, does that last throughout life, is that when people can't,
Yeah.
like the background
Once
noise
it's broken,
becomes-
it's broken. Once it's damaged, right?
Because my dad was in war and like he can't hear well at all, but it's because the background noise he can't differentiate it from
Oh, then that's
different.
yeah, that's different. Yes.
I have a question. As we get older, we start losing frequencies.
Yes.
What part of the ear? is
It's that's a very good question. So it depends on the loudness. So if you hear, sometimes it will just be this part that will be stimulated, that will fire action potential. So this one, the number of hair cells that you stimulate will tell you, will help you differentiate soft voice, loud voice,
Yeah.
or high pitch, low pitch. So it all depends on the sensitivity or intensity of the sound.
Well, there was a thing I saw on the news. A library had set up sound waves to deter birds. It was a very high frequency, and it would keep the birds away. But anytime any children would go to the library, they'd grab their head and scream because it was so loud and intense. But the adults couldn't hear. We're like, what?
Because children are more sensitive and they're the ones that can easily be affected by it. That's not nice.
Guys are
That's
Well, they
not
didn't
nice.
know. Once they
That's
found
why
out, they
at
disconnected
home,
it.
when I remember when my baby was just a baby, I just always, but you know, with your parents, you don't want to hurt their feelings. I come home, I used to teach night classes, and my mother, my baby, close to the TV, and the volume is so loud. I don't even have to go in through the garage door. I can hear the TV, and I look at my baby and I'm like, oh no. You know, my poor baby, the ears, because of that. But you have to be very sensitive with old people, okay? I'm old. Okay, now let's look at the. So, do you understand? For this one, here, here, it's all the same. It's hair cells that there's a membrane. You just brush on the hair cells, you hear. The same thing here, the same thing here. You brush on the hair cells, then you will realize you're moving. Look at this for the vestibule. The vestibule is the one that helps us determine our position sense. I'm going to go to this next slide. Look at, what do you see? It's the same thing. It's hair cells, see? And there's another membrane on top. The membrane is called otolithic membrane, which is gelatinous with calcium. So if you're deficient in calcium, maybe you can have problems with hearing also. And I'm going to go to the next slide. Look at, I just want this slide because, see, look at this guy. You bend, whatever. See, the gelatin will just slide, brushing against the hair, generate action potential. That's how you say, oh, I'm looking up, looking down. Because the hair cells get brushed. Then you generate action potential. Then you go to the temporal lobe. And of course, everything has to be correlated with what you see. Very nice, isn't it? Same thing with this one here. This semicircular canal detects movement. So this one, the vestibule, just detects your position. Now when you're shaking, how do I know I'm shaking? Moving up, shaking my head, nodding yes or no. Here, look at in the semicircular canals. There's a bulge right there called the ampulla, and it's the same thing, hair cells again. There's a membrane. So the membrane, just like a jello, will brush off the hair cells. Then you determine what you're doing. Very interesting, isn't it? You heard of seasickness? So they say the reason we have seasickness is because there's a conflict in message. You're sitting down. So your temporal lobe is receiving the message that you're not moving. But then your eyes, you're looking at moving stuff. So your eye is telling your brain you're moving. So there's conflict you become seasick. That's why they say if you are prone to being seasick, you focus on something that doesn't move so that your eyes and your ears are telling your brain the same thing. Okay? And you're done with Bio 241. I can't believe it. It went by so fast. So don't forget, Tuesday, expect lecture test for chapter 14 and 15. Then right after, you do one last review for your muscles. But I'm confident because I've asked you to cut the section again and again and again. You just need to remember your eyeball, your brains, this one. Okay?
Here.
And then right after lecture, we do comprehensive review for your final exam. Then you use the rest of the time to prepare for your lab. And then Thursday, lab exam. And after lab exam, comprehensive review again. And then final exam on Tuesday. Okay? Good luck, everybody. See you next week. Oh, Brandon and Joseph, let me just check your papers, okay?